When we talk about work, the first thing I do is I always bring up the work energy theorem, right? If we do work on a system, because basically work is force times distance. It's this meaningless thing to kids, right? So what I try to tell them is look, this is important, right? The work energy theorem states if I do work on a system, it gains energy equal to that work, right? If I take this mass and I lift it, it now has energy, right? There are clocks that can run for 2 weeks on them. The energy is stored in a mass as it descends. So I did work, this thing gained energy, right? We've got a bow, compound bow like this. I can do work on this. I exert a force on it over a distance. This thing now has energy. If I had an arrow, which would be a violation of the policy of no weapons at school, right? But if I had an arrow, right, I could give that energy to that arrow. The arrow would go flying, right? I can exert a force on this object, not lift it, right? But I could just go, right? I can throw it. And that, the teacher, Heidi Gorka, loves that. Okay, I throw it, it gains kinetic energy, right? And then I always say, okay, well, if I move this around and slide it, I'm doing work, where does that energy go, right? And the kids are like, well, it disappears, right? The energy is destroyed or something like that, right? And then I say, okay, well, what if we put temperature sensors on the bottom now? What's going to happen? Oh, right. Anyway, random energy. And then I like to do, when we actually get to energy, I like to challenge them to find some energy that's not nuclear energy, right? And they'll say, oh, well, gasoline. And I'll say, well, gasoline comes from plants. Plants, millions of years ago, right? But those plants grew under the sun. They got their energy from the sun, and the sun is a nuclear power plant, right? And I'll just trace everything back to nuclear energy, and most of the energy we encounter comes from nuclear, right? If they say, well, the energy of a moving baseball, I say, well, who moved it? How is it moving, right? And then a rock up on the mountain, well, how'd that mountain get up there, Anyway, it's mostly nuclear.